Hello everyone, in this video I will be showing to you how to create a simple crossbow system in Roblox Studio using quadratic equations. Let's get started. So first you're gonna have to get a crossbow model. I have this crossbow model that was made by a friend, but anything can work, it's just for a show, so it looks good. And you will also need an arrow model, which I put here in replicated storage, and it's basically just this arrow. Make sure your arrow has a hitbox at the top so it can detect when it hits, and you can make the hitbox a bit further in front of the tip of the arrow. Now let's get scripting. First, you need a config script, which will be all the math and literally everything. And the local script is just the local actor. You also have a fire event, which is basically going to fire when the tool gets activated. So let's get started by coding the local script. So what we want is that whenever we activate this tool, we fire the event with the mouse hit, because the server cannot access the player's mouse hit because it doesn't know which player it is looking at. So let's create a variable for the tool. This is just tool.parent. This. Let's create an event variable, which is basically tool wait for child fire event. Let's also get the player. So in a local script, we can easily do game.players.localPlayer to get the local player, and then mouse is just player get mouse. Now it's really easy. Tool.activated, so when the tool is activated, let's connect to a function and fire to the server mouse.hit. Okay, so now when the tool is going to get activated, meaning when you're going to have it equipped and click it, it's going to start firing this event. So we need now the config script, or the main script that retrieves it. So let's create a tool first. So the tool is the script of parent, and let's get the arrow template. So your arrow that we put in the replicated storage earlier, which is basically here. Wait for shell arrow. Okay, now we need a few parameters like the speed and the lifetime of the arrow. So there are a few techniques we can do this. Lifetime. So we need the speed of the arrow. I'm gonna set it to 150. We need the gravity. Well, it's just workspace of gravity, but we have to divide it by 2. And the arrow lifetime is how long the arrow is, how long the arrow takes to disappear when it hits. Now we need to get the run service. To get frame events. We need the run service. Now let's create a function to fire an arrow, and we need a few things. The player, which is just a player, we can make type checking, and a mouse hit, which is just a position. So first let's get the character, which is just the player.character, and if there is no character, we just return. Then we need the humanoid root part. So local humanoid root part is character, go and find its first child, humanoid root part. And same thing, if there's no HRP root part, then return end. Okay, now let's clone the arrow. Local arrow equal arrow template colon clone. Then arrow dot parent equals workspace. You can even put it into a folder if you want to. Now make sure your arrow is anchored. If not, it's gonna break because the physics are gonna interfere. Let's get started with the math now. So let's create a start position of C-frame variable. I mean, not a C-frame, but a position, which will turn into a C-frame. Dot arrow dot position. So the start position is basically the arrow you have put into the model, like before it gets launched. So you have this, and the arrow is just right there, and this is where the arrow is gonna go for. So make sure to have that and name it. Make sure to name it arrow. Once we have it, we can make our arrow move with pivot to the start position. So we need to make this a C-frame. So C-frame dot new start position. Really easy. Now we need to get the direction vector of the arrow, which is basically where the mouse is pointing at, and the start position. So local direction equals mouse dot hit dot position. So yeah, it's because mouse hit is a position, minus start position dot unit. Okay, and now the velocity in general physics and math is just direction times the speed. So it's just the direction vector times the speed. But the direction vector is got to be normalized, and it's gotta like be a unit vector. Otherwise, it's gonna get faster when it's not in the correct direction. I will show. Okay, so we just multiply direction of speed. So this is really important because this makes it so each component of a vector is between 0 and 1. So when we multiply the speed, it's always in bounds. Now let's calculate the previous position, which is basically the start pose right now. Now we're going to create a connection which will be binding to the heartbeat. So create a connection, and connection equal run service dot heartbeat colon connect function and delta time. I'm gonna make it dt. Okay, so the first thing we're gonna do now is applying gravity. So the velocity is really simple to apply gravity. We just add a vector where the y component is just the gravity times the delta time. So it's just gonna look something like this. So we can just do plus equals vector for the new 0 minus gravity, because we're gonna be like, it's gonna add times delta time 0. Now we're gonna compute the next position. So local, we can do next pose or new pose, whatever you want. Position plus velocity times delta time. So it adds those and multiply this with the delta time, so it moves using the velocity. Velocity is just speed. It comes from the Latin word velox, which means fast and everything. And now we're gonna raycast to make sure we can hit the players and stop on walls, because right now it will just move infinitely. Now what we gotta do, we are just gonna create a raycast. So the origin is basically the previous pose. The direction is basically the next pose minus minus the previous pose dot then the raycast params, we can just do raycast params.new and just don't put anything. Okay, now check the result, and if the result that instance that parent is not the arrow, then we gotta also check arrow, and we also gotta check if it's not the tool, and then we can do our stuff. Local hit equal result dot instance local model equal hit dot parent. So to check if we hit the player, we can basically create a humanoid and model colon find first child of class humanoid. If hum, then let's just take damage. Let's take damage. How much we can do is the formula, which is the speed divided by math at random 9 to 11, 12, I don't know. So basically, the faster the arrow is, the more damage it will deal. So that's pretty cool. You can adjust those values to your likings. Okay, now we gotta update the arrow. So what we can do is that if we do not find an instance that is a humanoid, result that instance parent colon find this child humanoid. So it's basically the else situation. Well, parent child of class humanoid, then we just move the arrow. Pivot to C-frame but new result dot position result position plus velocity, and then we just disconnect the connection, and now we can just delay by our lifetime function. Oops. Like that. If a row, then the row colon destroy. You can use debris service too, which is a good idea. Now we just update the position of the arrow because we haven't been doing that yet. That is really easy. I'll go C-frame. I'm gonna call it CF. C-frame dot new. Next position. Next position dot velocity, and then arrow colon pivot to C-frame, and previous pose equal next pose. Okay, so that's pretty much it. Now we just gotta connect the event. Fire event, server event, go connect, fire rule. Okay, let's test it. Okay, so we got our tool, and it just stops right when we launch it. Interesting, but it does point. It just does not correctly update. Okay, so as you can see, we get an error here that tells attempt to text nil with instance. So I'm gonna tell you how to fix this. So just move this big block into this. So yeah, it was a little mistake. You just had to move. That's why we get this error. Make sure to return. So it ends. Okay, now it should work. Alright, that's really good. As you can see, the arrow hits the ground and it has a nice quadratic area. Let's kill the zombie. And as you can see, the arrows disappear within a few seconds and they get into the ground a little bit. Boom, they're gone. As you can see, we can hit the wall. And they get into the wall a little bit because that's how Roblox updates the heartbeat. So it's pretty cool. So another way to create this with lifetime is using debris service, and it's also a really good way. So I'm going to show you how to do it. So the debris service is basically a service that allows you to add things to I don't know, death note lists, and just basically it disappears after some time. So let's just remove this debris service code. Add item, which instance, which is basically our instance, which is basically our arrow lifetime, and that does the exact same thing. And I think it's kind of better because it uses less threading, so it's a bit more efficient, I think. Now you can customize the script as your likings and everything. See, it works the same. Now you can add sounds, you can add effects like trailing effects, but this is a really simple way of showcasing. Now I want to tell you that it's not the best way to create a crossbow, because this costs a little bit of calculations. A few techniques that many game devs use when launching an arrow is, instead of launching the full model, you can just launch a particle that looks like it. So it's pretty nice, and it gets a bit more optimization. But in a little project like this works fine. Goodbye.